Kami memiliki tugas untuk menjawab tantangan dan juga permasalahan yang ada di Indonesia maupun di global melalui pemanfaatan mikroorganisme yang ada di Indonesia. Saatnya kita berdiri sejajar dengan negara lain, karena kita memang bisa dan kita harus bisa. Dengan visi yang jelas, kuat, kolaborasi, PMT bisa.
Kecepatan arus globalisasi semakin berakselerasi dan berdampak pada perubahan kehidupan. Penguasaan ilmu pengetahuan dan teknologi melalui pemanfaatan hasil riset dan inovasi menjadi kunci utama agar kita dapat terus bersaing di dunia internasional. Untuk itu, pemerintah membentuk Badan Riset dan Inovasi Nasional (BRIN) pada tanggal 28 April 2021 berdasarkan Peraturan Presiden Nomor 78 Tahun 2021.
Keputusan Presiden Republik Indonesia Nomor 19M Tahun 2021 tentang pengangkatan Kepala Badan Riset dan Inovasi Nasional. Dengan rahmat Tuhan Yang Maha Esa, Presiden Republik Indonesia menimbang dan seterusnya, mengingat dan seterusnya, memutuskan, menetapkan, dan seterusnya. Ke-1, mengangkat Saudara Laksono Trihandoko sebagai Kepala Badan Riset dan Inovasi Nasional terhitung sejak saat pelantikan.
Sejalan dengan Ketua Dewan Pengarah Ibu Megawati menyatakan Research for Nation atau riset untuk kepentingan bangsa. 1 tahun mengabdi, BRIN terus meningkatkan kontribusi riset dan inovasi terhadap pembangunan nasional. Salah satu wujud nyata adalah dengan melakukan pembangunan maupun revitalisasi 4 kawasan sains dan teknologi atau KST yang merupakan kawasan terintegrasi berupa fasilitas laboratorium riset, laboratorium pengujian, fasilitas industri, baik perusahaan pemula atau startup maupun UKM untuk skala kecil atau uji coba, ruang kantor tenan, co-working space, ruang pertemuan, ruang pameran, dan fasilitas pendukung lainnya. Setiap KST mempunyai fokus yang berbeda-beda sesuai dengan fasilitas pendukung yang tersedia di setiap wilayah. Kawasan Sains dan Teknologi Cibinong, yang kini menjadi Kawasan Sains dan Teknologi Dr. Insinyur Haji Soekarno yang berlokasi di Cibinong. Kawasan ini merupakan sebuah bentuk penghormatan atas jasa besar Presiden pertama Indonesia dalam melakukan pembangunan riset di Nusantara. Dahulu, kawasan ini dikenal dengan sebutan Life Science Center yang diinisiasi dan dicanangkan sebagai kompleks penelitian sejak 1964 oleh Presiden Soekarno. Memiliki luas lebih dari 180 hektar, kawasan ini diharapkan menjadi acuan perkembangan penelitian hayati di Indonesia. Di dalam kawasan yang juga merupakan zona hijau ini, terdapat berbagai pusat riset dengan berbagai bidang. Selain itu, ada Kebun Raya Cibinong dengan ribuan koleksi tanaman yang berasal dari 7 bioregion pulau besar Indonesia, yaitu Sumatera, Jawa, Bali, Kalimantan, Sulawesi, Nusa Tenggara, Papua, dan Maluku yang akan jadi ekowisata. Yang menjadi sumber oksigen, tetapi juga sebagai area serapan air bagi penduduk di wilayah Cibinong, serta Danau Dora yang semakin menambah keindahan. Saat ini dibangun beberapa fasilitas baru berupa laboratorium pendukung riset, seperti gedung genomik, keanekaragaman hayati atau KEHATI, Biosafety Level 3, BSL 3, In Vitro Diagnostic, IVD, Greenhouse yang akan menjadi daya tarik pihak mitra, baik dalam maupun luar negeri, untuk melakukan kolaborasi riset. Kawasan Sains dan Teknologi Serpong, yang kini menjadi Kawasan Sains dan Teknologi Profesor Dr. Ing Insinyur Haji Baharudin Yusuf Habibi, yang terletak di Tangerang Selatan, Banten. Dahulu bernama Puspiptek, kawasan ini menjadi bentuk penghormatan atas jasa Presiden ketiga Republik Indonesia atas beragam hasil inovasi yang sudah dihasilkannya. Kawasan ini memiliki fasilitas untuk pelaksanaan riset dan inovasi yang hasilnya dapat menjadi produk unggulan karya Indonesia dengan berbasis kepada program strategis nasional. Selain memiliki berbagai pusat riset dengan ragam bidang, kawasan ini ditujukan untuk menumbuh kembangkan kemampuan sumber daya iptek serta mendorong pemanfaatan hasil inovasi di tanah air dengan berbagai fasilitas. Di antaranya, laboratorium layanan pengujian kekuatan struktur, aerodinamika, uji emisi, fotovoltaik, iradiasi gamma, material, dan teknologi Business Incubation Center. Kawasan Sains dan Teknologi Profesor Dr. Samaun Samadikun yang terletak di Bandung. Kawasan ini menjadi bentuk penghormatan atas jasa seorang insinyur, pendidik, dan ilmuwan Indonesia. Profesor Dr. Samaun Samadikun, yang juga dikenal sebagai Bapak Mikroelektronika, merupakan kepala LIPI keempat yang telah berjasa pada perkembangan ilmu pengetahuan di Indonesia. Kawasan ini memiliki berbagai pusat riset untuk pelaksanaan riset dan inovasi, khususnya di bidang kebumian, lingkungan, elektronika, dan informatika, yang hasilnya dapat menjadi produk unggulan karya Indonesia. Serta kawasan sains teknologi Dr. Gerit Augustinus Yuwa Besi ini menjadi bentuk penghormatan atas jasa Bank Indonesia dan Direktur Jenderal Batan pertama yang fasilitas untuk pelaksanaan riset dan inovasi, khususnya di bidang ketenaga nukliran untuk kesehatan, pangan, pertanian, dan lainnya, yang hasilnya dapat dimanfaatkan oleh industri. Selain memiliki berbagai laboratorium teknologi, kawasan ini juga memiliki layanan sterilisasi dan preservasi kranium. proses melalui penelitian, pengembangan, pembinaan ilmu pengetahuan dan teknologi. Selain itu, juga untuk mendidik serta mendekatkan di inovasi nasional, tentu membutuhkan sinergi dan kolaborasi dengan seluruh pemangku kepentingan strategis untuk menciptakan ekosistem inovasi agar sebuah riset dapat memberikan nilai tambah, hasil inovasi dapat mencapai tahap komersialisasi dan produksi, serta mendukung kebijakan pemerintah dalam rangka mencapai tujuan pembangunan berkelanjutan.
Pengalaman menariknya, kita terlibat dalam ekspedisi untuk mencari jamur morel dan berusaha untuk mengkultivasi dan mencari media artifisialnya, dan ternyata tidak gampang ya. Yang menariknya kita mencoba untuk melakukan penanaman media di Gunung Rinjaninya.
Tahun 2024 tentunya banyak hal yang baru yang kita temukan. Salah satunya kita menemukan beberapa jenis enzim yang memang secara karakter belum pernah ada sebelumnya.
Ya, antara menarik dan tantangan ya. Kami banyak berdiskusi dengan mitra kolaborasi kami, misalnya terkait dengan santan gam. Santan gamnya itu adalah untuk pengeboran. Mereka ada spesifikasi tertentu. Nah, kami tertantang untuk bisa menghasilkan produk yang masuk ke standar KPI 13A yang sesuai untuk pengeboran.
Nah, kebetulan kemarin itu kita ada teknologi terimplementasi dari produk lokal sambil mengenalkan edible film. Itu tuh mereka lihat ibu-ibu yang antusias itu tuh bikin kita tuh semangat gitu. Cuma ya healing tipis-tipis sih kayaknya.
Kegiatan riset saat ini mungkin salah satu yang merupakan highlight ya dari kegiatan yang selama ini adalah menjadi bagian dari Pusat Kolaborasi Riset Biofilm. Kontribusi utama yang kami berikan adalah terkait dari pencarian bahan baku obat baru dari mikroba yang sesuai dengan kepakaran anggota riset.
Banyak dari penelitian kami itu ke arah metabolit ya, seperti fikosianin, karotenoid, biomasa mikroalganya sendiri, baik itu mengandung protein, karbohidrat ataupun lemak ya. Lemaknya itu adalah asal.
Riset unggulannya itu optimasi produksi untuk senyawa metabolit anti malaria yaitu boron-brin. Jadi kami sudah melakukan scale up sampai dengan fermentor.
Ongoing riset saat ini itu sudah ada produk suplemen protein yaitu dalam bentuk minuman atau yaitu micropowder yang memang ini sudah ada patennya dan insya Allah sedang proses lisensi.
Ya, selama ini ada beberapa enzim dan sudah ada beberapa enzim yang sudah di skala pilotkan. Itu enzim selulase ada 3 macam, endoglukanase, exoglukanase, dan beta-glukanase untuk produksi bioetanol.
Riset yaitu tentang multi-flavor. Kebetulan juga kegiatan ini sudah kami mulai sejak tahun lalu.
Terkait dengan bioremediasi, di mana kami menemukan 2 formula. Formula ini digunakan untuk mengurangi minyak di daerah pantai, sehingga nanti sedimen pantainya atau lokasi pantai yang tercemar minyak itu tetap bisa digunakan untuk proses rebuisasi atau penanaman mangrove.
Untuk pengendalian penyakit layu fusarium di tanaman pisang, ini dari mulai kegiatan eksplorasi, kemudian pengembangan agen biokontrolnya, teknologi mutasi dengan sinar radiasi gamma, dan juga kami mempelajari keragaman atau diversity dari isolat fusarium, khususnya Floctiaphor.
Nah, kita juga punya kesempatan berkolaborasi dengan Amano Enzim, ya salah satu produsen enzim terbesar di Jepang.
Kalau untuk kolaborasi sendiri, kita ada proyek bersama dengan PT Pertamina terkait dengan konversi karbon dioksida menjadi biomasa mikroalga yang bernilai tambah.
Kolaborasi dengan universitas, salah satunya dengan UB ya, atau dengan IPB. Bagaimana kalau dengan IPB kita banyak melakukan riset-riset dasar, pemanfaatan.
Kemudian kita juga ada dengan Indo ya, dan juga kami seperti kolaborasi lain dengan Cytiva Flower dan juga masyarakat Singkong Indonesia, dan sekarang juga sedang dibina dengan pupuk altim.
Saat ini berkolaborasi dengan Australian Center for Disease Preparedness (ACDP) dari CSIRO Australia. Jadi kami melakukan surveillance potensial zoonotic disease dari satwa liar di Indonesia dan juga dari sampel-sampel lingkungan.
Jadi tantangannya adalah dalam riset kita sama-sama paham ya, banyak kemungkinan-kemungkinan. Jadi dari satu biomarker kemudian kita coba membuat beberapa desain, seringkali adalah kecocokan dalam hal
Good morning, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Welcome to webinar on structural biology aids with topic protein purification strategy, held by Research Center for Applied Microbiology, National Research and Innovation Agency (BRIN). Today, Wednesday, March 12, 2025. In this occasion, we are honored to welcome Dr. Ahmad Fathoni, MA, Head of Research Center for Applied Microbiology (BRIN), our speaker, Ms. Shuwen, as a protein research health specialist at Cytiva, and our moderator for today, Dr. Dede Hari Yulianto, researcher from Research Center for Applied Microbiology (BRIN). Ladies and gentlemen, next agenda is singing the national anthem, Indonesia Raya. Ladies and gentlemen, next is opening remark from Head of Research Center for Applied Microbiology (BRIN) to Dr. Ahmad Fathoni. Time is yours.
Halo, Mbak Warda, oke ya?
Clear, Pak.
Okay, thank you, Ms. Warda. Good morning, everyone. Honorable speaker, our partner, our colleague from Cytiva, Dr. Shuwen as a protein research specialist at Cytiva and our colleague from PT Laborindo Sarana, Pak Andri, and from Cytiva ada Bu Widya as well, and all participants that has been joined this morning. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, good morning. First of all, I would like to thank you to our speaker, Shuwen. I think this is our second time running webinar with Cytiva. Hello, good morning, Shuwen. How are you? Nice to see you again. Yeah, and Bu Widya, Pak Andri, thank you very much for kind of opportunity for us to run second webinar with a specific topic on protein purification strategies. And as we know that we are now running collaboration platform of structural biology, and one of, for the moment, still big challenge for us here, most of us at BRIN in purification of a protein with a various sample sources, sizes, and type, recombinant, wild type, and many variables that still challenging to us, and hopefully Shuwen from Cytiva can share her expertise, her knowledge, her technology from Cytiva, how we can then not only help us but also accelerate this kind of platform, because we need to speed up actually the process to get the pure protein, because it's been 6 months, 6 months running, and then still few samples submitted to cryo facility. So that means there is something that need to be accelerated, and this part is in protein purification. Yeah, and hopefully everyone here, you please take this opportunity to discuss with expert Shuwen. And I think also here we have a student, Shuwen. So because for our platform we have 50 students, 50 student focus on structural biology. So that's quite a lot. And then this is also, I would like to inform our colleague that next month we are also going to run together with Cytiva and PT Laborindo on protein purification workshop using Acta Pure Micro, because we just bought a new Acta Pure Micro in genomic building, and next month we have a plan to run together with Laborindo and Cytiva. Of course, we will make a priority first for the PI first, because the PI who have the sample ready to be purified. So we will call for that PI to participate in this next workshop using our new Acta, not only Acta Pure Micro, but Acta Pure and Acta Pure Micro as well. I think without further ado, I will like to invite Shuwen to explain about protein purification strategy with various sample and type as well. Okay, thank you. So, Bapak Ibu Bismillah, I officially open this webinar. Thank you everyone for joining us this morning. So, Assalamualaikum warahmatullahi wabarakatuh. So, I give the screen back to Ms. Wardah.
Thank you, Dr. Fathoni. Ladies and gentlemen, before we start the agenda, we will have a photo session first. So all participants, please activate your camera, and for the committee to take the screenshot. I will start from slide 1, 2, 3. Second slide. 1, 2, 3. Third slide. 1, 2, 3. Thank you. Now we are going to start a presentation and discussion session, which will be led by Dr. Dede Heri Yulianto. Time is yours.
Okay, thank you, Ms. Wada, for time. And ladies and gentlemen, welcome to our webinar with the title for the protein purification strategy. Today webinar will be delivered by Shuwen on PhD. She is a protein research cells specialist at Cytiva, Southeast Asia region. And also she got a PhD in molecular microbiology from National University of Singapore. So she has a specialized as a protein purification, also managing product as the active protein chromatography system, protein purification resins, and also a BioCore protein analysis instrument and consumables. I think it is our great opportunity to understand how the strategy for the protein purification, and we will have a good speaker here, and I hope Dr. Shuwen can deliver the presentation for maximum at least 45 until 1 hour, okay? And then we will invite the audience for the question and discussion. If you have a question, please write directly into the chat or directly open your mic when the time for the question and answer sessions. So I invite Dr. Shuwen for your presentation, please. Maybe we didn't still hear your voice. Could you please try again?
Okay, let me check with Shuwen.
Hello?
Yeah, we can hear your voice, but still not so.
Also strong, right?
Yes,
I try to raise a little bit.
Okay. I think enough.
Okay. Thank you.
Yes.
First of all, I want to express my appreciation to BRIN. Last year, I think you make a big investment in Cytiva's solution for protein purification. This is a trust between BRIN and Cytiva. Thanks for your trust on us and also the expertise Cytiva protein purification, protein chromatographic system. So we also like to continue this kind of collaboration with BRIN together. We can hold each other's hands together to fully use your cryo-EM facility, and also Cytiva will provide a solution for protein purification. As of today, let me share my screen. Can you see my screen?
Yeah, Shuwen.
Okay.
Can see your screen.
Okay. Today we are talking about. Maybe I off my camera first, then we start to do the presentation. Okay, can you see my presentation?
Yes,
Yeah,
it is clear.
but it's not in the full.
I see.
Slide.
This is in the wrong.
I think you can use display setting.
Actually, it's display already. I just need to switch.
Maybe in the display setting. Shuwen in the mid. Toolbar.
Hide presenter view.
Share the correct screen. How about now? It's still
Yeah, still.
in the okay. I think
Yeah,
there is some.
the right side.
Yeah, display setting.
With
Go to the right, go to the right bar. No. I mean, after show taskbar, you can see the display setting. Display setting.
Or you can right click and hide presenter view.
Hide presenter view.
Yes, okay.
Okay.
Okay, all good now.
Okay. So today I'm going to talk about protein purification strategy. The first part, there will be several parts. I believe last part about resin selection, maybe some of you already hear. So I like to re-emphasize because Cytiva were really strong in antibody purification. Some more this year, we're going to launch another 2 antibody purification resin. So what's this meaningful to BRIN? Because from previous the video and also last year, our communication, I understand currently most of your work is focused on the biodiversity, natural extract. Then you try to understand the structure for some natural extract from your local plant or local organisms. But actual antibody is the biopharma trend for drug discovery, and some more. This is the most application for cryo-EM. So I believe in future, once you settle down, how to purify good enough and purity protein, and also you have a good hands-on skill for cryo-EM, you will go to this direction. So let's start with Cytiva's history about protein purification. Actually, we are first appear in the market is about resin, the Cephaldex, which is 1960s in the in insulin purification large scale. Then at 70s, we have sucrose CLB. Sucrose CLB means cross-linker, and protein A sucrose. So our first antibody purification resin launched in 1970s. Then later on, we launched the first lab ACTA system, is FPLC system. If you notice, if you notice the first resin launch and the first FPLC launch, actually there are around 20 years gap. So we started from the consumable first. Then at 80s, our pre-ACTA launched and our FPLC system launched. Then at monoclonal antibody, 1990s, we started. We have the source resin ACTA system. And actually after 20s, we further develop our consumable family, resin family, like MAB Select Sure resin, which now is still a very strong product in our antibody purification portfolio. Later on, I can give you more information about this one. And also, if you see here, high flow agarose resin. What is this? This is we call it modern resin. Last year, when we had discussion with BRIN about the resin selection, actually we strongly suggest you guys to choose the high flow agarose resin, because this resin we develop on previous experience about the sucrose. previous resin, we are using sucrose. Then later on, we're using agarose as a resin base. Later, I will tell you what's the difference of sucrose and agarose and why we developed this agarose, which have a high flow rate and also high binding capacity. And after 2010s, we even further develop a new resin. We add more product in our resin family, like MAP Select Sure LX, MAP Select Sure PCC, and capital resin. Now I move to protein purification strategy. So once you have a protein, you have a target. So you need to know what your target or your final experiment you want to do with your protein, purified protein. So someone like to do mass spec. Someone using the purified protein as an antigen for immunization. Someone to do the functional study, like the enzyme. They using SPR, YACO to study the enzyme function. And someone like you guys want to study the structure of the protein. So, but for pharmaceutical companies, they like to using the purified protein as a therapeutics. So different target or different aim of the purified protein require different amount of the purity of the final product, and require different purity, and also require activity and homogeneity. So we're looking at the amount from left to right. Therapeutic need the most amount because this is a pharmaceutical drug. And structure for you guys, you need a milligram, but now you have the cryo-EM. Actually, you already downgrade to microgram or nanogram. And for purity, of course, the therapeutic protein need the highest purity because we don't want to introduce impurity and have the side effect for the patient. So for therapeutic proteins, it need the highest purity, like more than 99.9%. But for functional study, if you only use purified protein to study some activity, then you might not need that high purity. 95% is enough. But definitely for structure study, you also need a quite high purity. So maybe between 95 to 99. So for activity, if you study, you use a final protein as a therapeutic, you definitely need it have the activity. Otherwise, you just give your patient some of the protein, not a drug, activity drug. So that's why during all this factor, amount, purity, activity, homogeneity is something you need to consider during before you set up your protein purification strategy. Then you can choose which resin you want to use and which protein, how many purification steps you want to involve. So let's see, purification strategy. Normally for Cytiva, if you're looking at the right plot, you will see we suggest 3 steps: capture, intermediate purification, and polishing. So normally for capture, it's the beginning of isolation, product from crude sample. So it's isolate, concentrate, and stabilize your target protein. And in the middle of the purification whole process is intermediate purification. Is further purify your sample, your target protein. So it's mainly to remove most of the impurity. So after second step, maybe your purity of protein already reached 90% or 95%. So for some customer or for some experiment, intermediate purification, we can stop at intermediate purification. Then for the high level purity protein you required, you need to add the polishing step. So the last step to achieve final high level purity. So you need to clean up of almost all impurity from your sample. But we need to think each step will reduce. You see the right, in this slide, you see the plot at the right. At the bottom, you will see number of steps. You add, and this color actually represent different purification technique like affinity, IEX, HIC, multi-mode, and size exclusion. No matter which purification step, purification technique you are using, you add one more step, your yield will be reduced. You can see the left side is a yield. So more step, you will sacrifice, you will lose more protein of your target protein. So actually we should target this part, 1 to 2 or 1 to 3 steps. We try to keep more than 50% of our initial sample. So using less step, as less as possible during your set up your protein purification strategy. Normally, we're looking at the left of this slide. One step protocol, you only need a capture step, skip intermediate purification and polishing. We have the moderate purity, so more than 80% purity, and we have high yield. If we can see here, normally 80%, about 80% of the yield of your target protein in the sample, original sample you can have. Then two-step protocol, you have capture and polishing. The purity is high, 95 to 99%, but your yield is reduced. You can see here. So, but this is a good balance, purity and yield. And the three-step, actually three-step normally is for the therapeutic purification. So they need to have capture, intermediate purification, and polishing step. They need a high purity, more than 99.9% purity of their final product. But of course, more steps, you will sacrifice the yield of your purified, your target protein. So this is a strategy at the beginning when you set up your protein purification process you need to consider. There are also other parameters. In fact, impactor for your setup your protein purification strategy. In this slide, we list down resin selection, operation space, general housekeeping, and hardware consideration. So let's talking about them one by one. One is a resin selection. You need to understand the resin chemistry and the bead size. So later on, I will talking about the bead size, capacity and residence time. Capacity is a little bit like the binding capacity of each type of resin. Each type of resin will come up with a data file. So we will indicate in our laboratory setup how much binding capacity for each resin. And the residence time is something your flow rate. When you inject your sample, how slow or how fast you want the sample injected. Of course, the faster injection will have a quicker purification process. But the interaction of your sample target protein with resin ligand will be less. So lesser interaction time or lesser residence time will have a lesser binding for your resin. Of course, we do have some study in our data file to show there is a maximum residence time, maybe 5 minutes or 15 minutes. So this all you can get from our data file. and a gradient or step erosion. Gradient, if you know, you are slowly increase one buffer's concentration, makes a gradient purification, and one at the screening stage. But when you come to your final product purification, you need to choose pH, at which pH your product can elute from your resin. So you will have the step elution. This one later I have example to share with you. And the last one is a productivity. It's how many gram per hour per liter of resin you can get your, how many gram of your target protein during 1 hour you can get from 1 liter of resin. So let's move to next one, operating space. So you need to have, this space is very important. Mean you need to have a certain parameter range, like your sample concentration. For 1 ml resin, you can inject how much sample. So how much sample, the range of the sample. So like 1 ml resin high trap column, you can inject 1 ml to 2 ml sample of your crude sample. You will have same binding capacity because each time your sample concentration should be different. So this one you need to consider. It's not you should have a range of sample concentration or sample volume, which you working under this range will not affect your purification result. And also buffer composition. No matter pH or ionic strength, mean the salt concentration, of course, or pH. Of course, pH, maybe we said is pH 5 can elute your final product. But actually for pH, maybe it's also working at a pH 4.9 to pH 5.1 or 5.2. Because each time the pH may be not accurate, we prepare the buffer. So you need to have a working range for your buffer composition. Gradient is the same. Step for, you need to screen the step for best protein stability and recovery, especially for antibody purification. Normally for last step of antibody purification, we need to using low pH. So after that, we need to neutralize the final product. Housekeeping, you need to have some general housekeeping, like the resin cleaning, sanitization, storage, and lifetime. This one is, we actually, if you notice, we have the column logbook. So which each time you are using your resin, your column with ACTA, you can, the column logbook automatically help you to record your column usage, how many times you use, then it calculates the lifetime for your column. And also feed the stock and buffer storage condition lifetime, which this one I think is not available in your ACTA Pure system. In ACTA Advanced for process development, customer is more important. For hardware consideration, currently your setup is Lab ACTA Pure 25M. Actually, ACTA Pure Micro is also under ACTA Pure 25M. So there are typical range of resin or column can working with ACTA Pure 25. So you need to choose the column under the which compatible with the system, and also pressure and flow rate limits. For each column, each system, we do have this parameter to provide. Okay, let's move to other key process development and scale up to consideration. I think this one I introduced and maybe not that relevant to you guys. This is more relevant to bioprocess customer, like scale up, they need to upscale. So at Cytiva, we are not only provide the lab scale, bench scale, purification chromatographic system, we do have the even smaller scale, like the screening And also, I believe you are using our PD10 column. It's a manual purification column. So you can pack your loose resin there using gravity to screen your suitable resin or condition. And we also have the 96 well plate. And robot column. Robot column should be 8 columns in a row together. And the predictor plate is 96 well plate. So that we have different format, like 196 well plates are all filled with the same resin. So you can screen in the purification condition. We also have 96 well plate filled with different resin, like the similar resin type. So you can screen which resin is better for your purification. Then we move to the bench scale, which is more relevant to you guys. We have the ActaPure system, we have Unicorn software, we have Acta1 system, and the compatible column. For the ActaPure system, actually we do have, I want to mention about Unicorn software. We are not only have the workstation, as previously I mentioned, we have the column logbook to help you to track your column usage. So this is quite a good feature or part of the Unicorn software family we provide. Okay, here show you the process development for screen to production scale. Here is a 96 well plate, predictor plate, and here is a robot column. Actually, robot column for you at the beginning of your purification, you also can consider this column format to optimize or choose your resin. And then we move to the lab scale. We have lab scale product, we have the lab scale system, then of course the manufacturer scale. Yeah, here is Unicorn software, the high throughput process development tool. We do have, I think you guys have the Unicorn evaluation software. But if you don't know how to use, please ask Satya. I think it's a good software. You need to explore more from Unicorn. To my understanding, a lot of customers actually they only using quite a limited function of our Unicorn software. Okay, we move to the chromatographic technique. Here in this slide, show you a protein with its four level of structure. And each protein have different, each protein have the 4 property. Like the net charge, we can using the net charge to do the ion exchange chromatography. And for the bispecific affinity, it can be the antibody. It also can be tag. So the affinity we can do the affinity chromatography. Then hydrophobicity. Is it hydrophilic or hydrophobic? So we can using this hydrophobic interaction to do the HIC chromatography, hydrophobic interaction chromatography. And also each protein based on the folding have different size. So based on different size, we can do the size exclusion chromatography. It also called gel filtration. Based on the net charge and hydrophobicity, we develop a multi-mode chromatographic. Means we put the ion exchange chromatographic together with the hydrophobicity in one resin. So one resin you can do 2 chromatographic techniques together, a combination of these 2 chromatographic techniques. But to be honest, most of the customer from research will focus on affinity chromatographic, ion exchange, and size exclusion. For affinity chromatographic, ion exchange chromatographic, hydrophobic interaction, and multimodal chromatographic, all using the band and the ELU mode, mean loading the sample, target protein binding with the ligand on the resin surface, and wash out, the impurity will wash out. So then using certain concentration or condition of elution buffer to elute out the target protein from the resin ligand. But size exclusion is using a different mode. It's just the separate different protein at the size based on their size. So normally size exclusion is the last step of purification, but at certain situation, it will be the first step of protein purification. Here in this slide, share with you the basic resin structure. So in our resin product, you will see the column. You see the white color loose resin, but how all of them are composed by the base matrix together with the ligand. So base matrix normally contribute to the productivity and the resolution. Mean base matrix can be different size. So smaller size have a higher resolution and higher binding capacity, but the flow rate, the back pressure should be very high. And normally, based on the chromatographic technique type, previously slides we mentioned affinity, AEX, HIC, multimode. Well, all of these four chromatographic techniques, there are ligands linked on the surface of the base matrix. Actually, base matrix is a solid support for ligand, and it's a polar structure beads. So the polar structure provides extra surface area for the ligand to attach on, and provide high binding capacity for your target protein. So you have more ligand, your binding capacity will be higher for your target protein. And the ligand actually can be anything from simple organic molecule to complex protein. And this mode of purification include AEX, HIC, affinity chromatographic, and multi-mode. But size exclusion is a special one. It's no ligand on the base matrix. It's only separate the product based on their size. So for base matrix requirement, if you still remember, in my first several slides, I introduced our first generation of resin is a Cytiva. So now we move to agarose-based because, of course, both this type of matrix have similarity. It's all inert support to ligand, and it have a very small it's a minimal non-specific adsorption. Mean only the part in your target protein related to the ligand can link to the resin, and it's easy to have different group covalent attached for ligand, because one type of matrix actually we were using to develop a different type of chromatographic product. Then we need it quite flexible to attach with different group, ligand group. And we also need it to have high binding capacity, even for large biomolecule. That's why the base matrix normally from Cytiva is a porosity structure. And good pressure flow property mean if you it can extend or tolerant to the high pressure or high flow rate, then you can have your protein purified very fast in short time. And stability under a range of experiment, as well as the cleaning condition. Like now we are trying to using different concentration of sodium hydroxide to clean our resin to do the CIP, and also for low or high pH is also important because like the antibody purification, it needs a low pH buffer to rule out your antibody and to do the neutralization. Okay, in this slide, you'll see the different bead size of Cytiva's resin product. On the top, you can see the three purification step we are suggest. Previous slides I introduced capture, intermediate purification, and polishing. And if you're looking below this three-step purification strategy, you will see capture normally involved with large size of resin, and the intermediate purification normally is a middle size of resin, and the polishing normally we are using the very smaller size of resin. So if you're looking at the bottom, it's a resolution and the back pressure. The bead size is smaller, the pressure is higher, but the resolution is higher as well. So when you set up your purification strategy, you need to consider the balance between the bead size or resolution you are looking for. Let me see. Here, I also want to highlight, if you look at the capture step, normally the is a size exclusion. Normally the affinity purification resin at the capture step is in bigger size. The modern high flow aqueous resin enable high throughput. In this slide, actually, I mentioned several times, previously our first generation of resin is sucrose. Sucrose 4 to 6B. It's 4 to 6B. I cannot remember what is this 4 and 6B indicate. Sucrose CL crosslink is the next generation. Then sucrose faster flow is at 1980s. Then nowadays we are using the capital resin or modern resin. Even we are still have the sucrose 460, sucrose CL, but actually we might gradually discontinue this. So once you face the resin selection, we suggest you can move to the modern resin. Here you can see the modern resin, the older platform resin. So I understand that some of our customers still using our legacy sucrose products, but we do have suggestion or replacement for each legacy resin in modern resin portfolio. And in modern resin, we increase the rigidity of the resin, enable high flow rate, and increase the flexibility in bed heights. And the modern resin have a high chemical resistance to assure long lifetime. Chemical resistance means you can using high concentration of sodium hydroxide to clean, do the CIP, clean in place. And this will increase your cost efficiency. And the modern resin developed with low durability. Depend on your purification stage. Actually, for different steps, just now we mentioned the capture, intermediate purification, and the polishing step. Actually, each step you have different parameter you need to looking at. For capture step, normally you when you choose resin, you need to looking at the binding capacity and the flow rate is a key factor you need to looking at. And for intermediate purification, the resolution is a priority. And for polishing step, the resolution and good recovery is the most important parameter you need to looking at. So this is set up the the base for how to choose a good resin or suitable resin for your purification strategy. Here is the method for CIPP in capture intermediate purification, polishing and polishing step. We call it CIPP, 3-step purification. Here is a suggestion for each type of purification technique or chromatographic technique suitable for which step. And their typical characteristic, selectivity, capacity. So you can see multi-mode can be used in capture step, intermediate purification or polishing step, all good for each step, these 3 steps, but need to depends on which, what is your target protein and what you're looking for. And from the left, I want to explain MM mean multi-mode, AC mean affinity chromatography, SEC size exclusion chromatography, IEXN exchange chromatography, HIC hydrophobic interaction, RPC reverse phase chromatography. We do have limited product for reverse phase, if I'm not wrong. So feel free, let me see. Yeah, we reverse phase chromatography. So this is suitable for organic solvent. But our system is have low tolerance to organic solvent. Till now, do you have any question? I will move to the so if you don't have a question, maybe I just move to the resin selection for different process. So this is quite a brief introduction. I will focus on antibody purification and viral vector, but never mind, because antibody purification, we do have a lot product to choose, and for viral vector purification, if I'm not wrong, we have some product to offer, but here I will focus on some new product, and I feel you guys maybe still still in the research space. Actually, I do have some introduction for the research customer, how to choose your his tag resin, how to choose your affinity resin. So we can leave that topic to next round webinar. So let's start with antibody purification. Here is a typical structure for antibody. And you can see the top is a Y shape. On the top is a fiber region in antigen binding fragment. FC on the bottom is a FC region. And for affinity ligand to antibody can protein A, protein G, protein L. So basically the FC region is a common region. Fiber region is more specific antigen, is binding with different antigen based on the antigen type, the sequence is different. So the therapeutic antibody are evolving in different various forms. Like a typical IgG structure is here. You can see here is a heavy chain and a light chain, and the FC region, the Fab region. There is a CHL, CH1, VH, VL, CL, and the constant heavy chain in CH is not changing. The variable heavy chain VH sometimes change. And the bispecific antibody, you see, is in this structure, you will see it's a symmetric left and side, right side are same. But in the next one, this bispecific antibody, you will see left and right side actually is different sequence. So this increases the binding capacity. It can binding with two types of antigen. On the top, antigen binding side is different. So it can binding with two types of antigen. So sometimes we can locate your antibody drug to certain place of the patient, and then to target the antigen, the disease factor. Now also have bispecific antibody. This is symmetric view, but the top and the bottom, the FC region have two ends. So FC region top end have the connect with antigen binding, one antigen binding site, and the bottom of the FC also connect with another antigen binding site. And also have the F fragment antibody. Here you can see at the bottom, the advantage to using the fragment antibody is can deliver very easy, deliver to the target easy, but the specificity may be low. So nowadays, a customer or a pharmaceutical company try to develop something smaller. Here show you Cytiva solution for antibody purification. Left side is a typical IgG structure, and at a different segment or fragment of the IgG structure, we are target. We have different ligand, like protein A ligand binding with VH and FC region, and protein L binding with VL region. And the right side affinity region. Left is affinity ligand. Normally is protein L binding with VL region, and protein A binding with VH together with FC. So right side of this IgG structure, you can see affinity resin Cytiva provider. Capital L, map select VL, target on the antigen binding VL region. And Prisma A, map select extra and map select target on VH together with FC. So it has double binding site on IgG antibody. And the map select sure LX target on FC region, only FC region. So this one is more generic. Most of the IgG antibodies using map select sure or sure LX to purify at the first step. But the binding capacity, Prisma A will have a better binding yeah. Because there are two, or more specific, there are two binding sites of VH and FC region. And later on, actually last year, we launched the map select, which is VH3, which is part of Prisma A resin ligand. It's binding with the VH region. You can see Prisma A binding with VH and FC. So we cut the FC binding domain from the Prisma A, form the map select VH3 region. So this one, if you still remember this slide, you will see the bispecific antibody normally happen on the VL and the VH3. VL and VH3. So these two domains is very important. So that's why we develop the VL, map select VL, map select VH3. And you guys never try out Prisma A. Of course, the performance for Prisma A is the best over rest of the antibody binding resin, but there are some reason. So this year we launched two more antibody binding resin. We call it map select sure 70, and another one is map select Prisma X. So some new things coming on the way. So once we launch it, I can, and you guys are also interested, I can introduce to you. Let's see the monoclonal antibody purification strategy. Normally, we suggest customer always start from map select Prisma A. So there are also different steps we suggest, like two-step purification process, Prisma A, and then using the multi-mode purification resin, capital adhere in press, which is B size is different, and its combination of IEX and hydrophobic interaction. So after 2 steps, you can have more than 90% purity of your monoclonal antibody. If you are using 3-step process purification for your antibody, for a general protein, you can start with MapSelect Prisma A, then using the capital impact is IEX resin, then come to the capital Q, another AX resin. So these two, if you notice, I assume this one is cation, one is iron. So you need to using different ion, charge. One is positive, one is negative. You cannot always using positive to do the polishing and intermediate purification. For the challenging monoclonal antibody purification, still using 2 steps, the 3 steps, but first step keep same as affinity purification using Prisma A. A second step using IEX. Then last step using the multimodal purification, either the adhere or adhere impress. It's a combination of the 2 step and 3 step general antibody purification. Okay, let's move to the product. First, the Prisma A, MapSelect Prisma A resin, which we launched in 2017. It's a new resin compared with previously our MapSelect Sure PCC. Then previously slides we introduced Prisma A have 2 binding domain, VH and FC region. So actually Prisma A is our golden standard, the highest binding capacity over legacy antibody purification resin like MapSelect Sure, MapSelect PCC. So we are not only provide the lab scale MapSelect Prisma A, we also have the screen platform for MapSelect Prisma A from 96 well plate from 2 to 50 microliter, and the robot column capacity is 50 to 600 microliters. Then we have the lab scale column, but this one is a high fiber resin. This one also high fiber, and we provide the manufacturer scale resin. Here is some protocol supporting protocol to support process development, like conventional antibody, specific antibody, and antibody fragment purification. So here show you the alkaline stability for Prisma A resin. Do you still remember for evaluate affinity chromatographic resin binding capacity, dynamic binding capacity, and alkaline stability is the most important factor. So here show you the alkaline stability and relative binding capacity. It reduced during the number of cycles you are using, because the resin we are using the sodium hydroxide, 1 molar sodium hydroxide to clean the resin. And we are using 15 minutes contact time between each cycle. And here is a comparison of Cytiva MapSelect Prisma A with MapSelect Sure LX resin. So from here you can see start from 25 cycle or 50 cycle. The MapSelect Sure using the 1 molar sodium hydroxide, MapSelect Sure DBC reduced to, but still 95%. But MapSelect Prisma A keep almost 100%. And at 150 cycles, MapSelect Sure LX dropped to 50% DBC. And MapSelect Prisma A still keep 90% of its DBC. So it provides all, if you choose the Prisma A, it have a lower resin demand and a high resin utilization, less extra cost for you. It can extend to the harsh cleaning condition. reduce the risk for viral burden incidents and lead to the cost investigation and delay. In this slide, actually we try to compare our resin performance with competitors one. But if you're looking at the plot from here, I intend to block to hide the competitor product's name. But blue color and the gray color is our is our competitor's resin product, equivalent to our Mag Select's Prisma A. And over different cycle, using the 0.5 molar sodium hydroxide to clean this three type of antibody purification resin. You can see our Mag Select Prisma A can last to 150 cycles, but our competitors' product only lasts to 120 cycle or 25 cycle, I can see. But the performance relatively remaining capacity is dropped to 40%. Another competitor can last to 150 cycles. The capacity relatively DDC dropped to 60%. So from here, you have a very clear comparison how Prisma A perform over the competitor. Here show you the two binding sites for Prisma A, FC and VH region. And using Prisma A, you have a different mode to feed your process intensification scenario. And we provide a total solution for antibody purification. That's why we are not only provide the lab scale resin, we also provide the manufacturer scale for process development product and also the impurity kit. Okay, we move to another product, which is Mag Select VL capture, which we developed. If you still remember the antigen binding site for each conditional antibody structure on the top. So VL is a very important domain or sequence for bispecific antibody development. So the difficulty for bispecific antibody development is product-related impurity. If you still remember previously my slides, for the normal monoclonal antibody left and right side is symmetric, but bispecific antibodies have different combination. In this slides, this structure is our desired structure. You can see 4 chain, 2 light chain, 2 heavy chain, and it all in different sequence. And we expect it can form a correct structure in different in one combination. We expect this combination, but during in the host cell, actually it's hard to form. It's only form you expect combination. Of course, there is some technique that can help you to have more expect combination like this one, but you cannot avoid to have this product-related impurity, like this, like this. So how to choose your expect product purification strategy, set a good purification strategy, play a very important role. So this is the reason we develop protein L ligand resin. At early stage, we have the protein L we have the protein L resin, we have capital L, but it's a leak the capacity, and the alkaline leak the capacity means binding capacity, and also the alkaline stability. So That's why before last year we do different map select VL on the ligand notation combination. We want to find a cost efficient protein L resin. And also the protein L resin, we hope it can stable when using 0.1 molar sodium hydroxide, which can reduce the risk of bioburden in the time, and also can increase the usage or shelf life of your use cycle of your resin, and provide a good resolution for product related impurity. Then last year we launched the map select VL. Here show you before last year we launched the map select VL. We have like a series resin. We call it capital L. So comparison of the map select VL new resin with the legacy capital L resin on different antibody, monoclonal antibody, 5 purification and domain antibody purification. From here, you can see the first graph show you the monoclonal antibody purification difference, the residence time, and how long we give the sample interact with the resin. And the left side is the DDC. And here show you the binding capacity for 5 purification versus resin time 2 resin comparison. The last one shows the domain antibody purification by 2 resin, let's say like VL and capital L. Obviously, this is 3 type of product purification, monoclonal antibody, 5 purification and domain antibody purification. Map select VL all have better binding capacity across all resin time. So it has a significantly increased domain binding capacity for map select VL resin compared to capital L resin for all resin time. Here show you protein L resin for capture and removal product related impurity using gradient elution. You still remember when we're talking about the key factor setup, you should have certain space in ion strength. Even your purify your or elute your protein at ion sodium chloride concentration maybe 0.5 molar, but you need to be efficient maybe at 0.4.8 to 0.5.2. You also can elute your protein. And this is talking about gradient elution of different pH. So here you can see from the plot, the pH is 3.5 to 3.1. So at 2 different pH, actually you can elute out different your target product with and your product related impurity. So your target product is left side, this one, which is pH 3.5. But your product related impurity, which is elute at pH 3.1. And when you do the screening, you can using the gradient elution. So this means you just set up in Unicorn your pH from 5.5 to 2.5. You will see different peak. But from here, after you run the SDS page together with some activity study, you confirm which pH peak is your desired product or your expected product. You will know you should elute your product at 3.5 or 3.1. Then you should set up the step-wise pH elution. So mean at pH 3.5, you keep elution for maybe 2 minutes or a certain column volume. This one should be 4 column volume or 5 column volume. Then if you after you get your expect the product, you further lower your pH to get your product impurity, remove the product impurity. So this is a stepwise pH elution. Previous is a gradient, actually it's more screening gradient elution. Now we move to another resin, is VH. So just now we show you map select Prisma A have two binding domain for the antibody. One is VH, one is FC region. So VH is a very important binding domain for the heavy chain. So we develop resin which only binding with the VH region of the heavy chain. So actually we just remove the binding domain of Prisma A of the XA region. So for the ligand for VH is VH region. And this resin also similar property, have a higher sodium hydroxide tolerance and also high binding capacity. More specific for VH region, same as a VL. Using the gradient purification, using the gradient elution to separate your product and the product related impurity. Then using some analytical method to see which peak is your desired, expected product. Then using the step elution. Here show you this gradient elution. Then after that, you using the step elution. Here can show you very clearly. At research scale, maybe the gradient elution is enough, but definitely for large scale protein purification, after you screening the pH for elution, you need a step elution to get more, or to get these two peaks separate, to mix them together. In this one, I show you the Prisma A map select VL and the protein A VH map select VH resin purification by purify the, I think, one bispecific antibody. So for protein for antibody purification, we are not only provide the resin, we also provide the knowledge behind. And this year, as I mentioned, we will launch two more antibody purification resin. One is map select Shuwen 70, another is a map select Prisma X. So we are preparing antibody purification toolbox for the customer. Okay, summary for this part. Cytiva maps monoclonal antibody toolbox. Always at current stage, please always start with map select Prisma A, then move to the ion exchange polishing step and intermediate purification and polishing step. In here, I like to highlight 3-step purification. You see, first step is affinity. Second step is cation exchange. And the last step is an ion exchange. So you cannot second step using cation exchange, third step also using cation exchange. You must change the ion positive and negative charge. Okay, I almost moved to the last part of my sharing. Before I start the last part, can I ask, do you have any question? Okay, if no, I will continue for selection resin for viral vector purification. Nowadays, there are different vaccine or pharmaceutical drug development. Vaccine is viral vector is one important target molecule for pharmaceutical industry. So it can be the size of the purification target actually is different. Monoclonal antibody is the smallest one. Then moving to the virus, adenovirus, and then mRNA, and lentivirus, and you see the EV isozyme purification, plasmid purification, and enveloped virus, even LNP purification. So we do have some solution for other all this purification. Like we have, if you purify virus like influenza, we have the capital D virus can be used. For virus which with negative charge, you can using the ion exchange resin like capital Q or capital Q impress to fish out your negative charged resin. And we also, if you have a large molecule, you can actually, we have capital Q 700 and 400, which is a flow-through mode for separation. Here show you very clearly the capital S Q sucrose faster flow. If you remember, Q sucrose faster flow is our legacy resin, using the sucrose as a base metric. Capital S is our modern resin, which we are using the more agarose to develop. So compared with the sucrose, agarose base or matrix have a higher flow or pressure tolerance. So mean you can using higher pressure. In this result, actually you can clearly see the pressure for capital S, it can extend even to 3 bar without change the velocity. But Q sucrose, once the pressure up to 0.5 or 1 bar, the velocity is changing. So here is a comparison for adenovirus purification. Previously, we have a reference process for at the left, using capture using Q sucrose XL, and polishing using sucrose for faster flow. And the new process we suggest using capital Q impress, which is modern resin, then polishing using capital Q 700. From the transmission electron microscopy, you can see very clearly the normal process have a clear adenovirus. You see the impurity is much more lighter than the reference process. Here show you the result. Reference process, the light blue is a viral particle. Reference process, the normal process have a high yield of viral particle, but the reference process is less. And the debris means the impurity for the normal process is less compared with the reference process. This one. Okay, here I like to move to the capital Q, show you the result, capital Q impress, how clean capital Q impress purified adenovirus. And you see, left side is a chromatogram, UV absorption at a different fraction, 2 to 3, 4 to 7, 8 to 10. And the right side is SDS pitch. And one is starting material, 2, 3, you can match this two results. So you can see the 3 is wash, and 4 to 7 is HCP, and 8 to 10 is a elution peak. 8 to 10 is here. So 8 to 10 is much more clean than before. Last, I'd like to introduce our capital core product. We have 2 capital core products. One is 700, another is 400. Traditional, from this picture, you can see left side is a traditional affinity protein purification. Right side is a capital core technique. left side, the impurity is a blue color. Target protein is impurity is light. It's a green color. Target protein is blue color. So traditional traditional method is target. Let me see. Yeah, target protein is binding with the target protein is binding with the ligand, and the impurity is flow through. Impurity is outside the flow through, and for capital core, it's different. Target protein is flow through, blue color, but the impurity is trapped by the capital resin. So that's why if you purify the virus, because virus particle normally is big, so it will flow through, and the small DNA fragment or host cell protein will trap inside the pore of the capital resin. So because the size difference of the impurity with the pore, so it can attract more impurity. Then you can using more column volume of your product. So basic structure of the capital resin is the surface. It has a 5 micromole in active shell, and the octylamine multimode ligand, very strong protein binding, is on the pore, in the pore surface area. So the particle size is around 85 micrometer, with an inner outer layer. This one is 5 micrometer. And the octylamine ligand on the surface and is designed with a pore similar to SEC. And this octylamine ligand are both hydrophobic and positively charged. So it can affect over a wide range of pH and sodium chloride concentration, can have a very high efficient multimode binding of various impurity, and is small enough to diffuse through the shell and enter the core. This result show you can see the load volume of your sample. This result compares the Safro 4 faster flow with capital core 700, because capital core used to trap the small impurity like DNA fragment and impurity protein, and your viral particle will flow through from outside of the resin. So you can load a high volume of your sample. Then from here, highlight the loading capacity for capital core is much more 260 times than the Safro's 4 faster flow, and the recovery rate is much more than the Safro 4 faster flow. A summary for resin selection. One is for monoclonal antibody purification. Please always, at current stage, always start with the capture step and followed by the IEX or multimode purification. Then for viral vector purification, we do suggest that we have capital resin can choose. Capital core 400 and 700 actually is a combination of size exclusion with multimode purification, and it's trapped the impurity inside the pore. Okay, I think that's all from me. Maybe I pause here. Do you have any question? I stop share.
Okay, thank you so much, Shuwen, for very nice presentation. So now we invite the audience for the question. Please, if you have a question, just raise your hand and you can open mic. Is there any question? So, Shuwen, I have one question about the capital. So, you have present about the capital for purification of monoclonal antibody and also virus. So maybe most of the audience also here working with the protein enzyme.
Great.
Is it also available, this capto, for the enzyme purification?
You mean capital resin or capital core?
Both.
Actually, capital resin, we have multiple chromatographic technique. All the resin called capital something. Capital Q, capital impress is capital resin. We have different type for you guys to choose. Actually, I want to highlight map select is one type of capital resin. It's just we're using map select to name it.
Okay. So capto is good for the collecting.
And
yes, capture.
Yes, yes, we do have capture for capto.
Okay. Okay. One more question. Do you have any I think most of the researcher need, although we can do also by ourselves, but
yeah.
I think it is better if the Cytiva can provide the list of the column and the publication, what for the protein purification is suitable. I mean, because sometimes the researcher is difficult to find to select the good.
Yeah, definitely. For brochure, we have the different resin selection guide. I think PT Lab can share with you. If PT Lab cannot find, let me know. I have the link I can share with them. We also have different application note. I think you guys just feel free to let us know what you are doing. We will provide the solution.
Okay, great. Thank you so much. So we invite audience here for the question. Also in Indonesian, no problem, and then we can translate your question to English, please. And also you can ask about your specific results regarding your problem during your purification process. It is open for your question, please. Any question?
If no question, maybe can I ask, have you guys started using the ActaPure Micro?
ActaPure Micro is now still development here, and we didn't start yet. But we wait for the sample.
Actually, normally ActaPure Micro, you should using ActaPure 25M. Last year you have purchased. You also have ActaGo. You're using the Acta that system to purify large amount of samples. Then second step for polishing, you can using ActaPure Micro. We do have some deck or example to share, and I'm not sure, are you purify any membrane protein? Actually, membrane protein is very tricky. The amount is quite small. So ActaPure Micro is more suitable for that.
Okay. Yeah, I'm not working with this animal.
It's okay. It's okay. Next time, if we can have more discussion, we are also open for bring customer. You guys can raise up any question. We are happy to support.
Okay. So, is there any question? Anyway, I think it is very interesting in your how you distinguish how your strategy to choose the column and the resin during our preparation. Then I understand about this situation, this strategy. Yeah, but maybe another question from the audience, please. No question. I think Yeah, Swen, I think we are the committee very happy if you can provide the link of the brochure and I mean the strategy for the using the column and the rest.
Yeah, definitely. Yeah.
Yes. Thank you so much, Swen, for
Yeah,
your
thank you.
presentation, and I will give back to Miss Wada. Thank you, everyone, for the participation. Yeah, please, Miss Wada.
Thank you,
Sorry,
Dr.
Pak Dede. Sorry, Pak Dede.
Yeah.
Hello, Shuwen. Thank you.
Yeah, hi, Fathoni.
Yeah. So this is, I think, out of our topic today, but I would like to maybe you can introduce a bit about our upcoming workshop, because after this webinar, I'm going to discuss with Bu Widya in my office regarding our upcoming workshop. Maybe I don't know whether you already been informed by Bu Widya if next month we are going to run a workshop on protein purification using after pure micro or after
I know. But I
Yeah,
think
so
this part Satya will be more involved in.
all right, so okay, Dr. Sata will come over here.
Yeah, Satya will. I can support you on site or online, like Teams or this kind of. I don't mind on site. I also don't mind if I need to look at my schedule. And actually,
Okay.
my customer from Singapore, Dr. Tan, also asking about you guys.
I see. Or maybe, you or Bu Widya, could you please, give us a bit briefly about our next workshop, maybe, mungkin Bu Widya.
Vidya, over to you.
Just as early information for participants. So if they're interested in this kind of workshop, they will register to this workshop.
Okay. Maybe I will discuss more detail with Pak Fathoni first about the agenda and the expectation for the secure schedule from Satya is around mid-April, Pak, especially for intense on-site training for Acta Pure M and also Micro. So I would like to discuss that things before we go further. But so far on that time, Satya have a lock schedule for us lah. I need to align with the BRIN team as well. And that's the update I would like to share to you today by today. And also the next collaboration step. Sorry, Pak, I cannot hear your voice, Pak.
Oh, sorry, muted. Yeah, thank you, Widya. Sorry about, and I hope that we have no problem anymore with the column, because we have purchased all of the list that you propose actually, and so for the next workshop next month, if you are asking about the expectation after the workshop, we have to generate a pure protein from it. So we don't need to worry about how many days it takes. So we will provide the days, but from the workshop, we hope we will get the pure protein from it. That's our target, because in our first workshop, I think the work was not done yet. But for this time, hopefully, we'll get pure protein. Ready submit to KIM. That's our target. So Shuwen and Dr. Saya hope we can meet next month and do this together. Thank you.
Okay.
Oke, silakan kalau nggak ada Bapak Ibu, nggak ada pertanyaan, kita bisa ke Mbak Wardah.
Okay, thank you. Thank you, Mrs. Shuwen, for a very interesting presentation. And as a token of our appreciation, we will give a certificate for Ms. Shuwen. And as a speaker, thank you very much for sharing your valuable knowledge.
Thank you. It's my great
Thank you,
honor.
Dr. Sun.
Yeah, thank you.
See you soon ya.
Yeah, see you soon.
after Idul Fitri, yeah, we are
Raya.
in Ramadan month.
Okay, ladies and gentlemen, we have finally come to the end part of this webinar. Before I close this session, I would like to ask Head of Research Center for Applied Microbiology BRIN to give us some short closing remark to Dr. Ahmad Fathoni. Time is yours.
Thank you, Mbak Wada. Again, thank you very much to Dr. Shuwen for your talk and also discussion. Hopefully, because yeah, I hope we can have long collaboration between BRIN and Cytiva specifically because with this structural biology platform, we will run. It is like a long project, yeah, not only 5-10 years, but maybe yeah forever. When we have a budget to explore our biodiversity, that's why close, strong, long collaboration with Cytiva for the moment, I think, will be mutual benefit, yeah, from both sides, Cytiva, Lapurindo, and also from BRIN. And yeah, thank you everyone for participating this webinar today, and hope to see you next webinar and also next workshop with Cytiva and PT Lapurindo Sarana. Thank you. I close this webinar. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Fathoni. Ladies and gentlemen, this is the end of our agenda for today. I'm Wada Tuharia on behalf of the committee. I would like to say thank you very much to our speaker, moderator, and all participants. And if you want to know more about Research Center for Applied Microbiology BRIN, you can check our social media on Facebook, Pusat Riset Mikrobiologi Terapan, and Instagram at prmt_brin. You can check the information of the webinar speaker on the Instagram story highlights, and you can also check the recorded webinar on our YouTube channel at PR Mikrobiologi Terapan BRIN. See you in the next event. Wassalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Okay, everyone. Thank you.
Thank you. Bye-bye, Fathoni.
Yeah,
Bye-bye,
thank you,
everyone.
Bob,
See you
Andri.
next month. Bye-bye.
Okay. Yeah, see you next month.
See you.